So glad you're here. My name is Keith Barker. Here is question 1 of 12. It is multiple select, so make sure you select at least 2 answers or more before you click on submit. And there's 120 seconds on the clock. This topology, switch 5 is on the far right-hand side. It forwards a broadcast on VLAN 10. Where would the source MAC address be learned on any of this topology? There's 4 answers on the board, at least 2 are true. Good luck, everyone. Well, I'm super pleased about switch 4 fast Ethernet 0/1. I am. And the reality is every single answer on this board is accurate. It's true. Don't shoot the messenger. But what I'd like to do is talk with you just for a moment, a little bit of tutorial about why the MAC address is where it would be. And to do this, let me show media. So there's our topology. So let's imagine we have a customer here. We'll call it Bob's computer. And Bob is on an access port that's associated with VLAN 10. And Bob sends a broadcast. And a layer 2 broadcast. Could be an ARP request, whatever it is. So he's going to forward a broadcast, and the question is, where is that going to be learned? Now, I know that switch 5, as that frame from Bob enters the switch, let's say the frame ends with A, B, C, D. That's the last 4 characters of Bob's MAC address. It's going to be learned right here. Let's call it port 9, because the frame entered here, and the source MAC address is that. And so switch 5 says, oh, for VLAN 10, this MAC address lives here. Fantastic. So part of this magic is to understand how a spanning tree is going to forward. And you know what? I've got a picture I'd like to show you. Let me see if I can find it real quick. I think you'll like it. Let me see if I can bring it up real quick. And go to downloads. Here it is. It's yeah, this is a great one. Great picture right here. You're going to love this. So this is a big purple flower. And you might say, Keith, what in the world is a big purple flower? What has that got to do with helping me understand spanning tree? This may be the key for you. This may be the key as far as understanding it for the rest of your life. Let me put myself in this picture here. All right. And I've got my pen out. So a big purple flower. So I'd like you to think of that in your mind, if you would. A big purple flower. Big purple flower. In fact, it might be hard. It's not a tiny flower. It's a big purple flower. So whenever you need to think about spanning tree, think about a big purple flower. And here's the play-by-play on that. The very first thing that's done in spanning tree, if we have a few switches, so we have switch 1, 2, and 3, that'll work, is the first thing is we're going to elect the root bridge. That's the very first thing we're going to do. So big purple flower, before we start saying who's going to forward, who's not going to forward, who's going to block or discard, we want to do big purple flower. And so the B is for the root bridge. Now, we're going to select one of these 3 switches if they're all supporting the same VLAN. Let's say it's VLAN 10. And the one that is going to be the root bridge out of these 3 is going to be whom. So somebody type that in for me if you would. Just go ahead and type it in the comments. Who becomes the root bridge? That's my question. Here we go. I like Lum's answer. It's great. It's the lowest bridge ID. It's the lowest bridge ID. It's the lowest bridge ID. Every time. No matter what. And so you might say, well, what's the bridge ID made of? And the bridge ID is the priority plus the VLAN number followed by the base MAC address. And that makes up the priority. So we really can't say it's going to be switch 1 or switch 2 or switch 3. Oops, I just put myself in I get myself out of there. We can't really say it's switch 1 or 2 or 3 until we know what the bridge ID is. So the value is the bridge ID, also called BID for short. So out of this topology, let's imagine that one of these, and let's get a volunteer. Which of these switches would you like to have the lowest bridge ID? Because the priority would be the same, so the base MAC address is going to make it up. But just the first answer that comes in, we'll choose that switch 2. Great. I love it. It's from Constantine. Great. So we'll say switch 2 is the root. So that's right here. And ta-da. So step number 1 is done. We've elected a root bridge. Now, a root bridge has something very, very special going on with it. And a root bridge is that all of its ports are designated. I'll put a D there for designated. And the question might come up, well, Keith, what does designated mean? It's pretty simple. Designated means that I'm forwarding away from the root. That's it. That's always true. Designated means I'm forwarding away from the root. So the root switch, the root bridge, is all of its ports for that VLAN are all going to be forwarding. And they're forwarding away from itself. So all of its ports are designated. It wins that function of being a designated port for all the ports on the root bridge. Great. So that's step number 1, is identify the root bridge and all of its ports are forwarding. Now, I heard a joke that I can't repeat online, but I'm going to modify it. And it's the joke is, credit is interesting, credit. Some people get it and some people don't get it. So with spanning tree, there's going to be an election for the root bridge. And one person wins that, one switch for the VLAN wins that. That becomes the root, and everybody else loses. They're all losers. All of them, except for the root bridge. Sorry. Now, so I'm going to go ahead and circle everybody else that didn't win, and I will put them in green. So these are I'll call them losers, because they lost. They didn't win the root election. They're not the root bridge. And every switch in spanning tree that is not the root is going to have one root port, and that's this next piece right here. So on everybody except for the root bridge itself, every switch is going to have one for the VLAN, one and only one root port. And it is the port that is closest, lowest cost to get to the root. That's it. So let's imagine all these links are 100 megabits per second. And switch 1, let's go ahead and label these ports. I'm going to label them 1, 2, 3, 4, 5, 6, 7. Great. And so on switch 1, if all these interfaces are the same cost, like they're all gigabit or they're all 10 gig or they're all 100 gig, whatever, they're all the same cost, switch 1 is going to be hearing BPDUs advertised from the root that says, hey, the cost to get to me is 0. And then the local interface cost, if it's 4 or 19 or whatever it is, this switch is going to compare the BPDUs coming in and say, well, that's going to be my root port. So that's my root port, says switch 2. Our switch 1 is port 2. And switch 3 is going to use this port right here as its root port. And that's step number 2. Remember, big purple flowers. Elect the root bridge based on lowest bridge ID. Make sure I'm not covering anything up here. And then secondly, everybody who's not the root bridge is going to have one root port. That's it for the VLAN, one root port. And I say for the VLAN because we want to focus on one VLAN at a time. All right, so Keith, what's the third step? I'm so glad you asked. Big purple flowers. We elect the root bridge. The losers elect one root port. And then the F is fight. Fight. What are we fighting for? Every segment on the network, think of every switch port as a segment, and some switches share the same segment. Every segment needs to have one designated port per segment. So between switch 2 and switch 1, switch 2 is the designated port. It's forwarding there away from itself. And port 7 is forwarding away from itself. So those are already covered. And then switch 1 and 3 have their root ports. And the question now comes in for this segment right here. Let me change that color. Let's use, how about light blue? That'll work. So this segment right here, between switch 1 and switch 3, they're going to go into step 3 for that. It's fight, 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 fight. We need one designated port for that segment right here. Just one. And there's going to be a loser here. So one port on one of the switches is going to be designated, and the other side is going to be blocking, or you could call it discarding if you want to with rapid spanning tree, but it's not going to be forwarding user traffic. It's going to be blocking. So the question is, when we fight, how do we know who wins? And the answer is between these two switches, which are both, they're not the roots. They're not root bridges. These two switches on the segment, they're going to say between them, 1 to 3, who's got the lowest cost to get to the root? And switch 1 says, my cost is 4. And switch 3 says, my cost is 4. Oh, okay, so we can't use that. It's based on lowest cost. So what do they do next? The cost is the same. Next, they compare their bridge IDs. And switch 1 says, my bridge, they both are losers. Let's get that straightened out. Switch 1 and 3 are both losers. They both did not become the root bridge. However, they both have a bridge ID. And now, as far as who gets to be designated for this segment, they're going to have a little contest, sending BPDs back and forth saying, okay, our cost is 4, but who's got the lowest bridge ID? And switch, let's say it's for VLAN 10, 32,778. Let's say that's the priority dot and then the base MAC address. So the base MAC address is not the MAC address on an interface. The base MAC address is the MAC address that Cisco gave this switch when they built it from the factory. It's you can do a show version and see what the base MAC address is. So if both of them have the same priority, which is a combination of the priority value plus the VLAN, so if it's 32,768 by default plus 10 for VLAN 10, it would look like that. But if they're both the same, then it's down to the base MAC address portion of the bridge ID. And so if one of them had like 0C124 and the other had 0C12E, which is numerically higher, this one with the 4 would have a lower, therefore better bridge ID, and it would win. Let's say that's switch number 1. So it would become designated on this port, and then switch 3 would go ahead and do blocking. That's how it works. Big purple flowers. I would love you to share that with somebody. Walk through it logically, because it'll be important for solving spanning tree type questions and also troubleshooting why spanning tree isn't working or why did it do that. And so big purple flowers. All right, so going back to this question, which isn't quite as colorful, but it's still a great question, is this. We have Bob here, who is in VLAN 10. Bob sends a broadcast, and the key is we want to figure out spanning tree so we can figure out who's forwarding, who's not forwarding. So for VLAN 10, switch 1 is the root. So I'll put that here. It's the root. It wins. That means port channel 12 is a designated port forwarding away from the root, and port channel 13 is a designated port forwarding away from itself. And that's one thing about winning the election for spanning tree is that you get to have all your ports be forwarding, and they're forwarding away from yourself, so they're designated ports. Now the question is, what about the rest of this topology? Let's identify the root ports, and I'll put those in red. R2 is a loser. It's not the root bridge for spanning tree for VLAN 10. But what would the root ports be? And basically, if we looked at the details, I believe the root port would be right here, root port, because of the cost going this way or this way would be worse. And then switch 3's root port would be here. And then switch 2 and switch 3 regarding port channel 23, one of them is going to win, one of them is going to lose. One's going to be designated, one's going to be... So if they're both the same cost from the root, the one that would win would be the switch that has the lowest bridge ID as far as who gets to be designated. And we'd have to look at the bridge IDs to determine that. So I'm not sure which of these would be win, but they're not the root ports. So we just leave that alone for a minute. On switch 4, what would the root port be? And I would like your feedback on that. And if you want to give me a guess on that, you can type that in the text in the comments and tell me on switch 4, we have really 3 choices. We have port channel 34 going left. We have gigabit Ethernet 1 going up, which is right here. And we have fast Ethernet going up. Yeah. Oh, wow. Okay. We have votes for gig 1. We have votes for port channel 34, but lots of votes for gig 1. And I would agree that probably is it. In fact, I would say it is it, because if switch 2 and switch 3 are both advertising the same cost to get to the root, which they both have port channel with Ethernet, 2 of them in it, then it would come down to basically the lowest cost on the interfaces being added to that. So these are fast Ethernet, Ether channel, and the gigabit would be a better cost. So I agree that would be the root port. And you know, we can verify that too. Let's just take a quick peek at switch 4. What do you say? As a team, let me bring up, oh, how convenient is this? I happen to have port 4. I happen to have switch 4 right here. So let me just hide the screen for just a moment. And let me bring this up. Show spanning tree for VLAN 10. And one of the benefits of labbing stuff up is that you can verify it and also be shocked by the results when you're not right. But yeah, you guessed it. I mean, that was the majority vote right there. And the reason it chose gig 0/1 is because its local cost was 4, and its cost for the port channel was 12. So the gigabit is better than 2 fast Ethernets in an Ether channel bundle. And so the advertised cost from switch 2, let's take a look at the topology and go back here. The advertised cost from switch 2 and 3 was the same, and so switch 4, its best option was to use gigabit 1, which had a lower cost than the Ether channel and a lower cost than the fast Ethernet. All right, so over here on this segment, though, who's going to be forwarding, who's not? So switch 1 is going to be designated on both these ports. When switch 5 is going to have a worse cost to get to the switch 1 through the route than switch 4. So these 2 ports can be designated, and switch 5 is going to choose a route port, and it's going to say this. Okay, what's the best cost? And switch 4 says, my cost is, we just looked at it, but whatever that cost was, it's going to be the same for port 3 and 2. So the cost is the same. It can't choose a route port based on better cost. Next thing it looks at is the upstream switch's bridge ID, which is the same. It's switch 4 both times, so you can't use that. And then the next one is the actual port priority, which is 128 by default on the sending switch. Lower is better, but they're both 128. Can't use that. And the last thing is the port identifier, lower being better. And so as a result, the advertised port identifier is that's lowest is gig 1, fast Ethernet 1, which would cause port 3 here to be a root port, and we would go blocking on port 2. All right. So if that's the case, and Bob sends a broadcast, let's go ahead and put that in. Let me put that in yellow. It'll be fun. All right. So the broadcast goes. So I'm going to put a little. Yeah, broadcast. Bah. There it is. Okay, so the broadcast would go into the switch. The switch would say, I need to forward this all ports associated with VLAN 10 and any trunk ports associated with VLAN 10. So some of these are trunks as well. So that would go out here. And that means that switch 4 would learn about that MAC address right here on port 1. And then that broadcast would, I didn't really analyze this with you yet. But we can. But the root port, it'd be forwarded up here. So switch 2 would learn about it right here, Bob's MAC address, and switch 2 would forward this on its root port. And so switch 1 would learn about Bob's MAC address on port channel 12. And because switch 1 has a designated port here, that broadcast would also be learned on switch 3 on port channel 13. So my guess would be these 4 locations, which are switch 1 port channel 12, switch 3 port channel 13, switch 2 gigabit 0/1, and switch 4 fast Ethernet 0/1. Should we take it on faith, or do you want to go into the CLI and verify that's actually happening? I'll do it either way. Let's go ahead and just give me a chat if you'd like to see that or not. Oh, I love Andre. Faith, take it on faith. And everybody else is saying, CLI, we need to see the output. And Bilal is saying, I don't want to see it. Well, I've got a majority vote here. Wow. I think we should take a look at it. We got a majority vote on looking at it, so let's do that. And to do that, I need to generate a broadcast. So one of the things that I love doing is I love playing around with how can we simulate that. And one thing we could do is we could, on switch 5, we could create, or if we already have a switch virtual interface that's in VLAN 10, we could have switch 5 ping something in the 10.10 subnet that it doesn't already have in its ARP cache, and that would generate a broadcast for the ARP, which would then follow, and we'd be able to track that MAC address. So I think we should do that. All right, let's bring up the CLI, and let's go to switch 5. And to get to switch 5, I need to telnet over there. So there we go. So I'm sitting at switch 5 via, let's do a who real quick. So I'm just telnetted in from switch 4 just for a moment. Let's do a show IP interface brief. And it has a VLAN 10 interface. And let's do a show ARP. Look at the ARP cache. Let's do a show ARP VLAN 10 without the slash. Okay, so switch 5 already has these resolved, so it's not going to do an ARP for any of these addresses, but let's do a ping to 10.10.0.99. which doesn't even exist, but it doesn't matter because we just sent an ARP request, a broadcast that went through the entire spanning tree network. All right, that sounds great. The other thing I'd like to do is let's take a look at the interface for VLAN 10. Show interface VLAN 10. This is the layer 3 interface on switch 5. Oh, show interface. Oh, I put a little extra symbol there. It's like, why doesn't it like that? Okay, so here is the MAC address, the layer 2 address for VLAN 10's SVI, the switch virtual interface. And this is the MAC address that should be learned everywhere in the topology. So what I'd like to do is this. Let me just copy that. And in fact, I'm going to write it down. A841 is the MAC address there. And I'm going to exit out of here. And let's go back to all 4 switches. So that is switch 1. I'm just using a little Raspberry Pi as a terminal server. I've got a video if you want to set one up as well to get to each of these devices. All right, there's all 4. And I'm also going to use Secure CRT. One of my favorite features here is the command window where I can send the same command to everybody. So I'm going to right click, send commands to all sessions. Let's just show spanning tree root. I just want to make sure that works. And then there's a tab. Oh, I need to get rid of this guy. He's like, I don't understand that command. That's the Raspberry Pi itself. All right, let me just tab through here. Okay, so if we want to verify that MAC address, what we could do is we could do a show MAC address table. And we could pipe include. Oh, wait, so let's do show MAC address table for VLAN 10. And then a pipe include. And I'm just going to doing a control V, A841. So if I type this right, what this should do on all switches is show the MAC address tables, but only for MAC addresses that are in VLAN 10, and then only include out of that output addresses that have A841 in the output. And that should do that command on all 4 switches. Let me just clear off some screen and do that one more time. All right, so let's start on switch 4. Here's switch 4. FA0/1, which was one of our answers. Fantastic. Let's go to switch 2 in the upper right-hand corner of our topology. It learned it on gig 0/1, as we expected. Fantastic. Let's go to switch 2, then switch 3, and that learned on PO13. Is that what we thought would happen? Let me just minimize that for a moment. PO13. Oh, yeah. Switch 3, because switch 1 was designated. So switch 3, port channel 13. That looks good. And let's see about switch 1, which is right here. And switch 1 learned it on PO12, which is also what we expected. Now, is it true that this is a little bit above and beyond what you'd be asked to do for CCNA? And the answer is yes. Yes, because it's involving the port channel and lots of variables. But I wanted to make sure that it is critical that you're able to know about big purple flowers. Root bridges get elected first based on lowest bridge ID. Then all the losers elect one root port, which is closest to get to the root. And then after that, they fight it out to make sure there's at least one designated port on every segment in the network. That's it. Big purple flowers. All right, here's question number 2. Oh, they are going to be easier now. What caused port channel 12 to be the root port? Good luck, everybody. All right, what caused port channel 12 to be the root port? And let's see. First of all, this port channel 12, it is the root port. Now, both of those interfaces have a local cost of 12. So what's likely to have happened is on port 12, we had a better looking BPDU that came into us from the root. And that's the reason we chose it. And that's that's the answer to this question. I wrote it a little bit, vaguely, but that's the reality. We get a better, lower cost, a superior BPDU, and we think, wow, that's going to be our best path to get to the root, and we choose it, and that becomes our root port. All right, here's question number 3 of 12. Which option guarantees that a switch can become and remain the root bridge for VLAN 10? All right, which option guarantees becoming and remaining the root? Wow, got a lot of people on blue. All right, so this one right here, which a lot of people jumped on, that's a totally valid command. But what that would do is if we had some switches, just take 4, boom, 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 some cross connects for some fault tolerance, and we'll call it switch A, B, C, and D. If switch A is the root because it had the lower bridge ID, and then we went to switch D, and we said spanning tree, VLAN 10, root primary, it's going to basically, switch D knows what the current root bridge ID is. It's had the BPDs propagated down to it. It knows what the root is. And what it will do, it will lower the priority to a point where it's going to win and become the root. So if this guy is 32,768 plus, as is configured or default bridge priority, and this guy needs to beat it, he can simply lower it, and as a result, maybe it's 20K and change. It has to be a certain value, a multiple of 4,090. Was it 4096? Anyway, if he lowers his to 20K, he would become the root. I agree, but as far as remaining the root, what if somebody then went to switch A and said, "Oh, spanning tree, VLAN 10 root primary," that would lower him again below this 20K, and they would go back and forth and back and forth and back and forth. However, when we use this command right here, that's like, I call it ultimate limbo. ULTIMATE. Ultimate limbo. And limbo is when you try to go under a bar. Anyway, you go down to 0, you can't get any better than that. And so if you set the priority to 0 here, I guess there's a chance somebody else could set it to also 0, and then it'd be down to the base MAC address. But reality considered, if somebody sets the priority to 0, that's as good as it gets priority-wise. By default, Cisco runs a separate instance of spanning tree protocol for each and every VLAN. By default. Is that true or false? All right, it is true. Cisco does run a separate instance of spanning tree for each VLAN. What if we're using 802.1d, which looks like IEEE? The answer is yes, that's true. What if we're using rapid spanning tree, 802.1w? And the way I remember that is I'm hunting wabbits. And there's a cartoon that I grew up with Elmer Fudd and Bugs Bunny, and he would say, I'm hunting wabbits. Be very, very quiet. Anyway, so 802.1 rapid spanning tree. Still silly, but that's how I remember it. And yes, they do it with that too. There's a separate instance if we're running that. Now, if we get into multiple spanning tree, then you're actually forcing it to run less. But by default, with 802.1d, it is absolutely running a separate instance of spanning tree. Are you having fun yet? I am. I'm so glad you're here. All right, here is our next question. It is question number 5. True or false, 50-50 chance, the faster you answer it correctly, the more points you get, is it is possible for a port to be in a blocking/discarding state and a forwarding state at the same time. Is that true? Doesn't sound true. But is it true? All right. A little better than 50-50. What do you mean it can be forwarding and not forwarding at the same time? How the heck does that work? That's a good question. Let's take a look. It just so happens I have a topology here that it can help us show that. All right, let's pick a switch in our topology. How about switch? Let's pick switch 3. Let's do a show spanning tree. Press enter. We'll just look at all of them. So for spanning tree, he's the root, so he's forwarding everything for VLAN 1. And he is not the root for VLAN 10, so let's just check that out for a second. So on VLAN 10, we are forwarding on port channel 13, and we're root, and then we're well, I need to find some blocking. Hold on a second. Here we go. So port 34 there for VLAN 20, see how it's blocking? And see port 34 here? For VLAN 10 is forwarding. Oh, wait. Yeah. We're forwarding for VLAN 10 on port channel 34, and we're blocking at the same time on port channel 34 for VLAN 20. So that's why this question is true. It's not only possible, it's likely if you have two different routes for a spanning tree for two different VLANs, it's very likely you're going to have some ports that are blocking for one VLAN and forwarding for another one. All right, so now you know. Here we go. Question number 6. You guys are doing great. So glad that you're here. And based on this output, which of the following are true? Good luck, everyone. All right. Wow, that's great. Based on this output, which of the following are true? And most people voted on most answers, which all of them are true. That's fantastic. Good work. And you can go back to this video. I'll have the recorded version up tomorrow and analyze that. If you're like, whoa, why is that true? And you can go back and take a look. All right. Let's continue on. I'm so glad that you're here. We are more than halfway done. Here's question 7 of 12. Multiple select. Choose at least 2 answers before you click on submit. Which of the following are true regarding VLAN 10 based on this output? All right, which of the following are true? Ether channel is discarding frames, and a lot of you jumped on that. Great. And gig 0/1 is the best path to the root because it's the root port. All right, so this right here, this cost on this port, gig 0/1, that's the local cost. So let's imagine that somebody advertised to us the cost to get to the root of, let's see here, 12. We would take that advertised cost of 12, we'd add on our local cost of 4, and that would give us our total cost to get to the root of 16. This is also showing us the port that we are going to use to reach towards the root, our root port, which is also reflected down here as well. So Ether channel, port channel 34, it's in a blocking state. And so the thing is, when I was first learning spanning tree and rapid spanning tree, I was like, why? You know, rapid spanning tree, the ports aren't blocking, they're discarding. That's the state. But in a Cisco environment, whether we're using IEEE or rapid spanning tree, it's going to show blocking to represent the fact that it's not forwarding user traffic. And that blocking simply means that we're discarding frames. Traffic that shows up on this port from a peer, if it's transit traffic, like user traffic for VLAN, whatever, it's just going to go ahead and drop it for VLAN 10 because the port is in a discarding state. Question number 8, and then we'll take a look at the scoreboard at the end. When does spanning tree protocol need to block layer 2 ports? All right, and Constantine is mentioning regarding the output, the P. Let me just bring up a camera for this. Let me bring up that one. There we go. So in the output of the show spanning tree, in fact, let me show you. I've got a live interface I can just show you. Let me bring it up real quick. This is an important point, and if I've got a couple questions on it. If it says P to P right here, what that represents is that it is full duplex. That's what it implies. Now, if you're doing, this is hardware, so it is full duplex. But if you're doing it in software or emulated, who knows what that's going to show up like. But P to P represents full duplex. And then over to the right after that, if port fast is enabled, it would say edge. Blocking when parallel paths are detected with BPD is fantastic. Great job, everyone. And here is our next question. Question 9 of 12. What makes up the bridge ID? Okay, the faster you answer correctly, the more points you get. There's 2 correct answers on the board, and yellow is not one of them. All right. Wow, look at that. Look at that. Just tons and tons of points just flowing in for people answering that correctly. That's great. And another question we might ask ourselves is, when does the bridge ID matter? And I can think of 2 times. Can you? What are the 2 times the bridge ID matters? And if you know that, you'll be in good shape as well. We've talked about it already. Let's continue on. We've got a few more questions. Here's question number 10 of 12. It is multiple select. Choose at least 2 answers. Which statements, plural, are true regarding this output? All right, the default cost for gig 0/1 is 4. Let's see here. What is this? Oh, I see. Oh, okay. So that's tough. So without even looking at it at a diagram, the default cost for gigabit for spanning tree is 4. Switch 4 is not a root bridge. And holy cow, we're looking at switch 4. Okay. And because switch 4 has root ports everywhere for all the VLANs, that's true. Because a root bridge wouldn't have any root ports because they'd be all designated. And let's see here, root of VLAN 1 has a priority set to 24,480. Let's see if that's true. So, oh yeah. So the root for VLAN 1 it says the priority is 20,481, but that's for VLAN 1. So that's 2480 plus the VLAN number, which would make it 2481. All right, great job. If you have any brain cells left, this is the time. Which root port will switch 4 use for VLAN 10? We've already walked through this, by the way. So it's just a matter of recalling that and answering as fast as you can correctly. All right. Great job. And we went through the logic of that before, how switch 4 is going to use a root port of gigabit 0/1 or that yellow one because if they're both advertised the same cost to get to the root from switch 3 and switch 2, then switch 4 adding its own local cost, that gigabit would be a lower cost, a better option than the others. All right, fantastic. We already looked at that output, so no need to go there again. All right, last question, but before we go there, let's take a look at the leaderboard. Wow, Diligent Emu, 16,509. Proud Bunny, Epic Duck, Balanced Ibex, and Smart Alpaca. Everybody's doing great. And up 12 places, Silver Chicken is the highest climber. All right, this is the last question. These are randomized, so I'm not sure which one this is out of the 12 questions I created for this quiz. And here it is. It's a puzzle. Oh, place them in the right order. Which order is used? Really, the diagram, don't even bother with it. Just put these in the right order when any switch is calculating its root port. Wow. Okay, so I'm looking at this chart up here and I'm thinking, there's some people who pulled off a lot of great points in the last few minutes of this quiz. And for VLAN 30, I think the winner of VLAN 30 was this guy. So he's the root, if I recall correctly as I set it up. So he's the root, everybody else is losers. And so for all the losers, when they're calculating their root port, they are going to use which interface has the lowest cost to get to the root bridge. So let's pick on switch 5. It's got 2 possible options. It could go A or B. And so if the cost is being advertised the same from switch 4 for both of those links, which it would be, and the local interface costs are the same, that's a showstopper because it's the same cost. And then it's going to take a look at the lowest advertised or received bridge ID. But unfortunately in this case, switch 4 is advertising its bridge ID as the designated switch for both segments. And because that's the same, that can't be used. But that's the order, which we discussed earlier. And then the lowest received port priority, which is the default of 128, which doesn't, pan out because they're the same. So that can't be used. And then it's the lowest received port ID, which in this case, I think it was port 1 up here and port 2 down here. And as a result, this top link would be chosen as a root port because of the lower advertised port ID. And that's why they're in that order. All right, let me go ahead and share with you. In fact, let's just take a peek. And we already verified the topology, so that's great. So let's go ahead and let's take a look at the winners table. Here it is. Congratulations, everybody. Proud Bunny, you did it.